Hi everyone, in this video we will be going over doubly linked lists, and I personally love doubly linked lists, and I hope you all will as well. As always, let's begin with a bit of motivation. And a bit of an aside, whenever we learn anything in this class, we always want to ask ourselves why. Why are we learning this? Why do we care about this new data structure? Why do we care about this new implementation? What benefits does it have over other things we've learned in the past, right? Why? I think that's the most important question you can ask in your class, and especially right now with linked lists and this example. So one downside of an SL list is that inserting at the back is much slower than at the front. We've looked at add first and add last, and we can kind of see that add last takes a lot more time. If I have a really long linked list, I have to go all the way to the back, right? And it's not that efficient, okay? So let's try to figure out a better add last, something that makes it just as fast as add first. Okay, so let's think about this, have some improvement. Well, one possibility is what if we have a last variable that kind of points to the last link? That's like one possibility. So the question is, would this work? Would add, get, and remove actually become faster with the last pointer? Okay, so let's think about this. Yes, all of these operations will become faster, or no, one or some of them may not. Okay, so highly recommend pausing, stopping for this question, really thinking about which operations might become slower, or will they all become faster? Okay, so the idea here is that remove from the end is going to become slower, right? The reason for that is if I have 50 at the end of my linked list, if I remove 50, I need to have access to 9, right? Well, we don't have any reference to 9. So if I were like kind of figure this out, I'd be like, okay, like let me also store the second to last reference, right? So I'll have a last and a second to last problem solved. But then if I remove the last and I remove the second to last, I don't have any pointer to the second to last, right? So we can kind of see here that remove isn't going to get that much faster at the end because we can't leverage that last pointer when we do remove, okay? But with that being said, we have made add last faster and we've made get last faster, right? So those two check, remove last unfortunately does not have a check. Okay, so let's try to make remove also fast. So pause here. Let's try to figure this one out together. Okay, so the idea here, I think it's a crazy cool idea, is we're going to add a backwards link from every node. So usually, if I have some linked list, I iterate forward with a dot next. Now I can also iterate backwards with dot prev. Okay, and this is the doubly linked list, also called the DL list. And this is an improvement from the singly linked list or the SL list. And that was the name of the SL list, singly linked. I'm not sure if I ever said that. Singly linked SL list. So doubly linked DL list. Okay. And one very important thing here is whenever we draw arrows in these diagrams, it's important to understand that these arrows are pointing to objects. They're not pointing to a field of an object that's impossible. Okay. What I mean by that is if we have some last variable and I say, what's what's last pointing to? It's not pointing to the item field of the object. That's impossible. It's pointing to an int node object. Okay. Visually, we kind of draw it sometimes pointing to the item, but it's really just pointing to this entire object. Right? Okay. So let's look at doubly linked lists. So we have our sentinel node, right? And we have our last, right? So we can kind of see here that when the list is has two elements in the bottom example. Last points to the last one, sentinel still points to the sentinel node, right? So yay, this like looks pretty good. And this actually supports add, get, and remove very, very fast for the beginning and the end, okay? So one catch here is that last sometimes may point to the sentinel, sometimes may point at an actual node. In which case, it's really confusing because we don't really know if last is actually pointing to sentinel or some actual thing, right? So this is an annoying special case, and we do not like special cases. So let's try to improve the structure of our doubly linked list to accommodate this. So one idea is let's have two sentinels. Let's have a sentinel at the front, and let's have a sentinel at the back, right? And this idea works. Completely working idea, okay? We have a sent front and a sent back. And sent back is just replacing last, right? Because the problem with last that we mentioned in the previous slide is that it sometimes points to the sentinel, and we don't know if it actually is pointing to a node or a sentinel. So now we just replace last with sent back. Okay, so this is the double sentinel approach with two sentinels. Okay, however, I think there's a slightly better way of implementing this. So that is the circular sentinel. Okay, let's kind of understand how this one works. So for the circular sentinel, we only have one sentinel. Okay, in the last example, we had a sent front and a sent back, but now we're just going to have one sentinel. Okay, so seems life is a bit simpler here, but the kind of tricky thing to understand is when we only have one sentinel, our linked list is circular in a way, okay? So we have a circular linked list that we can traverse in forward order using dot nexts, and we can traverse it in backwards order using dot prevs, right? Kind of looking at this example below, this is my sentinel. If I want to traverse this linked list in forwards order, I would access the dot prevs or the dot next. Oh my gosh, my bad. I would access the dot next, right? I would say dot next, and then I'd say dot next, and I go back to the sentinel and I know I've made it all the way, right? In a similar light, if I want to access in backwards order, I use the dot prevs, right? I say sentinel dot prev, we go to the last link. Then we say dot prev again, we go to the second to last, and we say dot prev finally, and we make it back to the sentinel. So we can see here there's two ways of really iterating through this linked list because of this circular sentinel. And I think that makes our life really, really cool as a programmer. Okay, so this is the doubly linked list circular sentinel approach, and this is how I prefer to implement Project One, so I highly recommend you all to do the same. Okay, so just kind of recapping, when we have our doubly linked lists, we also need our fancier sentinel node. Okay, so there's two approaches we kind of discussed. The first was the sent front, sent back approach. And the next one, the one I recommend, is having one sentinel node and the linked list is circular. Okay, so that's all for this video. The next video will be a short summary, so stay tuned for that one.